This is the Essentials of Algebra Final Exam Study Guide. So the vocabulary, I'll skip it. I will refer back to it as we come to it within the math, but I do want to jump into the math with you. Number one, which options represent a function? Explain why or why not. So remember, in order to be a function, each x value has to have exactly one y value. Each x has exactly one y. So looking at letter A, I see x values of -1, 3, 3, and 7. So right here, I see these, or this x value of 3 has two different y values, a 4 and a 6. So here I know that this is not a function because the x value of 3 has more than one y value. All right, letter B, I'm looking at this graph of a relation, so I want to think about the vertical line test. Is there anywhere that I could draw a vertical line and hit more than one of these points? And I don't see anywhere this would occur. So I could say yes, each x value has exactly one y value. All right, letter C. Again, I'm going to be thinking about the vertical line test. So I'm thinking about if I were to draw a vertical line, a line as straight as I can get it, of course, straight up and down. You know, would there be anywhere where I can move this line left or right and it would intersect this relation more than once? And I'm kind of visualizing moving it, you know, back and forth. And I don't think it's going to end up anywhere where it can intersect the relation more than once. So I would say, yes, this is a function. Again, each x value has exactly one y value. All right, and then letter D, again, I'm thinking about drawing a vertical line. This vertical line here does intersect the relation twice, so that means it fails the vertical line test. So is this a function? No. Each x value does not have exactly one y value. All right, letter E, I'm looking at this table of values, x values. They don't seem to repeat, so I'm going to say yes, this is a function. Each x has exactly one y. Letter F, I do see these two ordered pairs right here that have the same x value. In other words, if I were to draw a vertical line, it would intersect this point in the relation and this point in the relation. So because it intersects more than once, I know that this is not a function. So I could say no, it fails the vertical line test, or no, just by definition, each x value does not have exactly one y value. All right, letter G, we're looking at a mapping here. So remember with your mappings, all of these values over here are terms in your domain, and all of these values over here are terms in your range, and the arrows represent your pairs. So 5, 6 is an ordered pair, 5, 1 is an ordered pair, 7, -9 is an ordered pair. So here I see this x value of 5 has two different y values. So I know that this is not a function, no, and I could be specific and say the x value of 5 has two y values. All right, letter H, again, I have my mapping. I have my X's and my Y's. 1, 7 is an ordered pair, 6, 7 is an ordered pair, and 3, 7 is an ordered pair. So this is a function. There are no X values that have more than one Y value. Remember, the Y can have more than one X. This is a cheating Y, but it can't be a cheating X, and these are not cheating X's. So this is a function, and we can just say each X value has exactly one Y value. Okay, number 2, which representation shows all of these solutions of this equation? So you might remember that you can have like input-output pairs, pick an X, plug it in, solve for Y, so on and so on. But this key word here is all. The only representation that does show all of the solutions, meaning every single point on that line, would be letter A, because it is a continuous or connected graph, and it does have these arrows showing that it would keep going on and on forever, because of course there are infinite solutions to that linear equation. So you would want to, if you need to, rewind that, listen to it again, and then explain that down here, kind of, word it a little bit in a way that you're comfortable or that you can understand that before you move on. All right, number 3, the area A of a trapezoid-shaped garden is given by this equation. Hector knows the area of the garden, the width W, and the length of one of the parallel sides. He wants to find the length of the other parallel side, B. We need to rewrite the equation to solve for that parallel side, B. Show your work or explain your words. Okay, so to solve for B, we're going to start out with what's given to us, of course, which is A equals 1/2 W B plus C. So if I were to make an undo list, what is happening to my variable B? Well, my variable B is being added to C, and I know that happens first because it's inside the parentheses, so think about your order of operations. And then it's being multiplied by 1/2 W. Okay, so if we want to undo this, basically we're going to have to work it backwards. So the opposite of multiplying 1/2 and W is to essentially divide by them. So I'm going to take this kind of one step at a time just to break it down for you. If I want to divide by W, I can just divide by W here, and I can divide by W here. Okay, so I undid that multiply by W. Now, if I want to undo this multiply by 1/2, think about if I'm dividing by 1/2, your operations when you're dividing by a fraction is to flip it and multiply. So basically what we're doing is we're multiplying by a 2/1, because a 2 on top, 2 on bottom cancel, 1 on top, 1 on bottom cancel. But if I multiply this side by a 2/1, I'm going to have to multiply this side by a 2/1. So what I have left is a 2A over W equals, let's see what didn't cancel over here, is this B plus C. Now I'm going to keep working my list. The next thing in my list is to undo adding C, which means subtracting C. So what I'm going to have left is 2A over W minus C, because this entire thing is being subtracted by C, so I'm just putting it out to the side, equals B. Rewrite the equation to solve for W. You must show your work or explain with words to receive credit. Okay, so now we want to solve for W. So we're going to have to ask ourselves, what is happening to the W in this original equation? Well, W is being multiplied by 1/2, and it's being multiplied by B plus C. So if we start with what we know, like this, we're going to work it backwards. The opposite of multiplying by b over c is dividing by b over c. We're going to divide this entire thing by b over c. We're going to do the same thing over here. So we end up with a over b plus c equals 1/2 w. And then we're going to undo multiplying by 1/2, which we already know is flipping it and multiplying it. So we're multiplying by 2 on both sides. And then what we have is 2a over b plus c equals w. So you can see we're making these undo lists, asking yourself what is happening to that variable. Okay, let me work it backwards. It really can help you remember what to do first, what to do second, etc., etc. Okay, number 4, what is the solution to this inequality? So I'm just going to break it down with you. We'll work it step by step. I'm going to bring down the 2x, negative 6 times x, negative 6 times 3, 4 times 4x, 4 times negative 1, combine like terms over here. Add 4x. Let's see, I'm bringing my variables over here, so I got to bring my constants over here. So add 4 to cancel that one. We end up with negative 14 is less than or equal to 20x. So now you have to ask yourself, well, what is happening to x? X is being multiplied by 20, so to undo that, I'm going to divide both sides by 20. So I end up with x is greater than or equal to negative 14 over 20. Which if I want to get my x on the other side, I can do that, but then I have to flip my inequality as well. And then this can reduce to negative 7/10. So don't forget to simplify that fraction at the end. Might want to make yourself a little note. All right, number 5, excuse me. Fernando works between 10 and 30 hours a week. This function represents the amount of money he earns given the number of hours he works. Which statement best represents the domain of this function for any given week? The amount of money he works given the number of hours. It tells us right here, hour stands for x, and we know domain is the x value. That would have been a good one for the vocabulary. Domain is your x value. So basically they're talking about the number of hours. We know he works between 10 and 30 hours. So we want to find an inequality that says in between 10 and 30 hours inclusive. So that looks like letter B here. That's his number of hours worked. All right, number 6. What are the x and y intercepts to the equation? Show your work, graph the results on the grid. Okay, so for number 6, we're going to go ahead and start a new video since we're getting close on our time limit here. So video 1 is just numbers 1 through 5.